Policy sets and site assignment. Now that we have covered all 6 policy types at a high level, we need to understand how policies are packaged and delivered to sites. The mechanism for this is the policy set, and it is one of the most operationally important concepts in Prisma SD-WAN. A policy set is a named container that holds an ordered list of rules for a given policy type. You do not assign individual rules to sites. You assign an entire policy set. So your workflow is always create the rules, group them into a policy set, and then assign that policy set to a site or a group of sites. The 3-tier assignment hierarchy can be remembered with the acronym GSS, which stands for Global, Site Group, and Site Specific. A global policy set is assigned to all sites in the fabric as a baseline. A site group policy set is assigned to a logical group of sites that share common requirements, such as all retail branches or all manufacturing plants. A site-specific policy set is assigned to a single site that has unique requirements not shared by any other location. When multiple policy sets apply to a site, for example both a global set and a site group set, the controller merges them using a defined precedence order. Site-specific rules take precedence over site group rules, which take precedence over global rules. This allows you to define a common baseline once and then layer exceptions on top for specific sites without rewriting the entire policy for each location. This GSS hierarchy is what makes Prisma SD-WAN policy manageable at scale. Without it, a fabric with 500 branches would require 500 independently managed policy configurations. With GSS, you manage 3 or 4 policy sets that collectively govern all 500 sites. QoS. DSCP marking deep dive. DSCP, which stands for Differentiated Services Code Point, is a 6-bit field in the IP packet header that carries a quality of service marking. When a packet carries a DSCP value, network devices that understand DSCP can apply priority treatment based on that marking without needing to perform deep packet inspection themselves. This makes DSCP an important mechanism for extending quality of service policy beyond the ION device into the carrier network. The 3 DSCP handling modes in Prisma SD-WAN can be remembered with the acronym POM: Preserve, Overwrite, and Mark. Preserve means the ION device reads the DSCP value that was already stamped on the packet by a trusted internal device, such as a Cisco IP phone or a Teams certified endpoint, and forwards the packet with that value intact. Overwrite means the ION device replaces whatever DSCP value is on the incoming packet with a new value defined in the QoS policy, regardless of what the original value was. Mark means the ION device stamps a DSCP value onto packets that arrived with no DSCP marking at all. The most common deployment pattern is a combination of preserve for trusted voice and video endpoints, and overwrite for all other traffic to enforce a consistent DSCP scheme regardless of what internal devices may have stamped. This prevents untrusted endpoints from self-promoting their traffic to high-priority DSCP values, which would allow them to bypass your QoS tier assignments. The standard DSCP values you need to memorize for the exam or interview map to the EF, AF, and CS classes. EF, or expedited forwarding, marked as DSCP-46, is used for real-time voice. AF-41, which is DSCP-34, is used for interactive video. AF-21, which is DSCP-18, is used for business-critical data. The default class, with no DSCP marking or DSCP-0, is used for best effort traffic. The ION device maps these DSCP values to its internal WFQ queue so that a packet marked EF by a trusted IP phone automatically lands in the voice queue without requiring a separate DPI classification at the WAN edge. Path policy, SLA profiles and link quality metrics. An SLA profile in Prisma SD-WAN is a named object that defines the maximum acceptable thresholds for latency, jitter, and packet loss on a WAN link. Path policy rules reference SLA profiles instead of hardcoding quality thresholds directly into each rule. This separation of the quality definition from the rule definition follows the same reusable object pattern used throughout the Prisma SD-WAN policy framework. The three quality metrics in an SLA profile can be remembered with the acronym LJL: latency, jitter, and loss. Latency is the one-way or round-trip delay in milliseconds between the branch and a probe target. Jitter is the variance in latency between consecutive probe packets, measured in milliseconds. Loss is the percentage of probe packets that do not arrive at the destination. Each metric has a threshold value, and a link is considered unhealthy when any single metric exceeds its threshold. The ION device measures these three metrics using active probing. It continuously sends lightweight probe packets to a set of configured probe targets, typically the far end of the overlay tunnel or a public probe host. The probe results are averaged over a rolling window to smooth out transient spikes and prevent false failovers caused by a single dropped probe packet. The interaction between SLA profiles and path policy rules is the core of intelligent path selection. A voice SLA profile might set thresholds of 150 milliseconds latency, 30 milliseconds jitter, and 1% loss. A bulk data SLA profile might set thresholds of 500 milliseconds latency, no jitter limit, and 5% loss. Path policy rules reference these profiles by name, so a voice rule and a bulk data rule can share the same set of WAN links but apply completely different quality standards when deciding which link to use. NAT policy, exclusions and overlay traffic. NAT exclusions are one of the most operationally critical and most frequently misconfigured aspects of NAT policy in Prisma SD-WAN. Without proper NAT exclusions, inter-branch traffic that traverses the SD-WAN overlay gets incorrectly NATed at the source branch, which breaks the return path because the destination branch tries to reply to a translated public IP rather than the original private source IP. The rule to remember is captured in the acronym OER. Overlay traffic excludes rewriting. Any traffic destined for another branch or the data center over the SD-WAN overlay should always have a NAT exclusion rule that matches before any broader source NAT rule. Without OER in your mental model, you risk allowing a broad SNAT rule to accidentally catch overlay-bound traffic and translate it before it enters the overlay tunnel. In practice, you implement open edge routing by creating NAT exclusion rules that match the overlay destination prefixes, typically the summary routes representing all branch subnets and data center subnets, and setting the action to no NAT. These exclusion rules must be positioned above the source NAT rules in the NAT policy table, following the same first match wins evaluation logic that governs all other policy types in Prisma SD-WAN. A secondary use case for NAT exclusions is VPN or dedicated circuit traffic. If you have a dedicated MPLS circuit that carries private-to-private traffic between your branches and data center outside of the SD-WAN overlay, that traffic also carries private source IPs and must not be NATed. NAT exclusion rules matching those MPLS routed prefixes ensure the private addressing is preserved end-to-end across the MPLS circuit. The diagram on this slide shows a branch with both internet-bound traffic and overlay-bound traffic originating from the same LAN zone. The NAT exclusion rule at position 1 matches overlay destinations and permits traffic to pass without translation. The SNAT rule at position 2 matches all remaining LAN traffic and translates it to the public WAN IP. The correct ordering of these two rules is what determines correct behavior. Policy objects. Reusable building blocks. Policy objects are the shared vocabulary that all 6 policy types speak. Rather than repeating IP addresses, application definitions, and zone names inside every individual rule, you define them once as named objects and reference them by name across as many rules as needed. This object-centric design is the foundation of maintainable, scalable policy at enterprise scale. The 4 primary object types can be remembered with the acronym ZASP: zones, applications, services, and prefixes. Zones are the logical groupings of interfaces that define trust boundaries. Applications are layer 7 identities resolved by deep packet inspection, drawn from the built-in application library or custom application definitions. Services are Layer 4 port and protocol combinations used when application-level DPI is not available or needed. Prefixes are IP address ranges in CIDR notation representing hosts, subnets, or address groups. Application objects deserve special attention because they bridge security policy and quality of service policy without duplication. You define the Microsoft Teams application object once. The security rule that permits Teams traffic references it. The quality of service rule that assigns Teams to the video queue references the exact same object. If the Teams application definition ever needs to change, for example, because Microsoft adds a new port or domain, you update the application object in one place and both the security rule and the quality of service rule are immediately updated throughout all policy sets that reference that object. Custom application objects are essential for proprietary or internal applications not covered by the built-in library. You define a custom application by specifying the Layer 4 protocol, the TCP or UDP port number, and optionally a hostname pattern for applications that use dynamic ports over HTTP or HTTPS. The ION device uses these custom definitions alongside the built-in library during the application identification stage of the pipeline. Slides 11 through 20 Mnemonic Recap. This slide consolidates all new mnemonics introduced in slides 11 through 20. These extend the master framework from the previous deck. Together with the 8 mnemonics from slides 1 through 10, you now have a complete recall system covering every major concept in the Prisma SD-WAN policy framework. For policy set assignment hierarchy, recall, GSS. Global baseline covers all sites. Site group covers a named group, and site-specific overrides for individual sites. For security rule ordering, recall, SBG. Specific denies first, broad allows second, and the global default deny last. For DSCP handling modes, recall, POM. Preserve trusted markings, overwrite untrusted ones, and mark packets that arrive with no DSCP value. For network policy route control, recall, LBS. Leak to branches for site-to-site reachability, leak to services for security service chaining, and block from spreading to suppress sensitive prefixes. For path policy SLA metrics, recall, LJL. Latency, jitter, and loss. The 3 dimensions the ION device measures to determine whether a link qualifies for a given traffic class. For the 2 forwarding models, recall, DIA versus HUB. Direct Internet access for low latency software as a service breakout versus hub and spoke for centralized security inspection. For NAT exclusions, recall, OER. Overlay traffic excludes rewriting. Always put NAT exclusion rules above SNAT rules. For zone design, recall, GLVW. Guest, LAN, voice, and WAN as the 4 foundational zones in every branch deployment. And for policy objects, recall, ZASP. Zones, applications, services, and prefixes. The 4 reusable building blocks that all 6 policy types share. Thank you for your attendance. Please consider subscribing to the channel and liking this video.